Hello students, welcome to Sri Jayendra's Rank Zone classes. I am your friend and mentor for coming classes with respect to physics. This is lecture number 2 of a unit Laws of Motion. So let's begin with today's class. In today's class we are going to begin with the momentum, and from the momentum we are going to switch to the Newton's second law of motion. So let's first begin with the momentum. Let's have a look. What is momentum, or how can we define it? We can say that momentum is the quantity of motion contained by a body. It can be measured as the product of mass and velocity of a body, and that is represented by P. We can say that if mass of a body is m and velocity is v, then momentum can be written as P is equals to m into v. Yes, even in the previous classes, that means in 9th class, you have learned this. Yes, this is just a revision point of view. In CGS system, units of momentum is gram into centimeter per second, because it's a P is equals to m into v. And in SI system, it can be written as kg into meter per second. If I want to derive the dimensional formula of momentum, it can be written as P is equals to m into v. Mass, unit of mass would be a kg, unit of velocity it would be a meter per second. So dimensional formula of momentum, it's an m1 l1 t minus 1. We know that momentum, it is a vector quantity and whose direction is in the direction of velocity. So direction of momentum and direction of velocity would be the same. I hope these things are clear. Yes. Now let's conclude something from Newton's first law of motion that is related with the momentum. Now, according to the first law of motion, if no external force acts on a moving body, then it moves with uniform velocity. Now you know what external force is, what internal force is. Yes, so it says if no external force acts on a moving body, then a body must be moving with uniform velocity. Even it concludes that if no external force acts on the body, then the momentum of the body remains the constant. Yes, because it is moving with uniform velocity, and we know that mass never changes. So if velocity remains the constant, momentum as well remains the constant. So even from this we can conclude that when the momentum of a body changes, the body must be under the action of a net external force. So if momentum changes, there must be certain force that is acting on a body, and if momentum is not changing, that means there is no availability of force which can change the momentum. I hope these things are clear. Is it? Let's have a look. Certain MCQs. Momentum it's a product of mass into acceleration. No. It's a product of mass into velocity. Yes. The product of mass into displacement. No. It's a product of mass into speed. You cannot say speed because it's a vector, not a scalar quantity. Product of mass into acceleration. What is it? It's a force. Product of mass and displacement. Nothing. Yes. And product of mass and speed, we cannot define it. I hope these things are clear. Is it clear? Great. Now let's look at the next question. It says if two stones of same mass from different heights fall on a vehicle, which one causes greater damage? Greater damage can be created by the one which is having higher momentum. So an object which is having an higher momentum can cause a greater damage. So let's find it out. Let's suppose this is the vehicle on which it is going to be fall down. It's an height h1, and let's suppose this is released from here. It's an h2. So when this object reaches here and when this object reaches here, their respective velocities v1 should be equals to root of 2g h1 How did I derive this? It's a v square equals to u square plus 2gh that we have learned. This in motion in a straight line. And for this, it's a v2 should be equals to root of 2 into g into h2. So the momentum is m into v2, and here it's a momentum, it's an m into v1. So we can have an idea that higher the velocity, higher the momentum, and higher the momentum, higher the higher the damage. Yes, so the correct answer should be a stone from a greater height can cause greater damage. I hope those things are clear. Is it? Great. Let's have a look to the next question. What is the dimensional formula of momentum? It's an P, which is equals to mv, which is a kg into meter per second. So this can be written as m1 l1 t minus 1. Is it clear? Yes. So can you do this? Can you? Is it possible for you guys to do this? Are you sure? So now let's move to the second law. Let's move to the second law of motion. What does it say? It says that it is the rate of change of momentum of a body. It's a rate, that means divide by time. Always when rate word is there, that means it is divided by time. So it's a rate of change of momentum of a body is directly proportional to the applied force and takes place in the direction of the force. This is the statement of second law of motion. Yes, here you can see that one of the person is trying to kick the wall. So whatever amount of forces it is passing through the wall, a same amount of force has been passed back to the person. But if here he is trying to kick the ball, he is not going to get hurt. I hope these things are clear. So it is the force that you pass through the wall which will came back to us. Yes. So second law of motion tells us that there is a net external force acting on a body, and it relates to the net external force and acceleration of the body. It relates with two terms, relation with force and relation with acceleration. So let's have a look. What we can say acceleration? We can say acceleration is produced when a force acts on a mass, and the greater the mass of an object, the greater is the amount of force required to accelerate the object. So higher the mass, you require a higher amount of force to accelerate your object. So what we understood from this is that directly or indirectly we know what second law is. Maybe it is quite possible, that we don't know the statement, we don't know the conditions, but we are knowing that if force is acting on an object, then object must accelerate, and if object is having a higher mass, I required a higher amount of force to accelerate it. Is it clear? So let's find it out, the units of force. In CGS unit, we can write like this. It's a force is equals to m into a. We are going to derive this, but before we go through the derivation of this, let's just write it down, the units of this. We know that it's a mass into acceleration, and for mass it's a kg, for acceleration it's a meter per second square. So units of force in CGS could be written as gram into centimeter per second square or dyne, and in MKS or SI it's a kilogram into meter per second square or Newton. We have a very good relation, that is of 1 Newton is equals to 10 to the power 5 dyne. Please remember this, 1 Newton is equals to 10 to the power 5 dyne. You can verify this using the relation of N1 U1 equals to N2 U2. Yes, please try it by yourself. Now, how can I define a 1 Newton? What I can say that if a force produces an acceleration of 1 meter per second square on an object of mass 1 kg, then the force is called as a 1 Newton. We know that it's a F is equals to ma. If mass is equals to 1 kg, if acceleration is equals to 1 meter per second square, then I can write like this. It's a F is equals to m into a. This is equals to 1 kg multiplied by 1 meter per second square. And if it's a 1 kg into 1 meter per second square, it's a 1 Newton. So this is 1 Newton. Yes. Is it clear? So as of now, we know second law, we know first law. From this we can conclude that second law measures the quantity of force. That means a value of a force, or how much amount of force is being applied. Whereas first law just describes the concept of force, that how force could behave or what a force can do. Is it clear? Is it? So let's move to the derivation of Newton's second law of motion. Let's have a look. How could I derive it? So suppose a certain body is having a force F for time interval of dt, and within this duration the velocity of a body of mass m changes from v to v plus dv. Yes, what we can say, it's an initial momentum p that should be is equals to m into v. Here this changes. If I take a change in momentum, it is equals to m into dv, because here in this case mass remains the constant. So according to the Newton, it's a force is the rate of change of momentum. So it's a change in momentum with, yes, it's a rate of change of momentum. It's a dp by dt. So if I remove the proportionality symbol, I can add one constant. If f is equals to k into dp by dt, I am having a value of dp which is of m dv. So this is f is equals to k into m into d by dt of v. It's a dv by dt which is an acceleration. So this is f is equals to k into ma. And if k is equals to 1, I can write that f, a force, is equals to mass into acceleration. I hope these things are clear. Is it? Any issues? No? One more thing, that when we write like this, it's an f is equals to d by dt of p. We have a different relations, or we can have it something like this. Let's have a look, that if mass is constant, so the situation would be f is equals to d by dt of m into v. Let's say mass is the constant, so this is m into dv by dt, and dv by dt is the acceleration, that is force is equals to mass into acceleration. This is the first relation. Now let's suppose one of the relation is as a case 2, if mass of a body changes, if a mass of a body changes, this is what we call as a variable mass system. Now first, before we are started doing deriving this, first let me know that is it possible that mass of an object changes? Is it possible? Anywhere, any applications? Take your time of 10 seconds and let me know. Do you know any applications where mass of an object changes but its velocity remains the constant? Any instant that mass is changing? Let me help you. Let's suppose take one balloon and keep its mouth open, fill this, and let's suppose when you release it, air is moving out from this. So as air is leaving from the balloon, its mass decreases while it is moving, or it can move from the certain fixed velocity in an upward direction. Same is the case of space shuttle. Yes, it is having a fuel tank. So as soon as fuel is burning and it is moving in upward direction, its mass decreases. So there are certain more systems. We are going to look into that in the numericals as well. Yes, so there are certain systems which are having mass as a variable and their velocity remains the constant. So if it is the case, what I can write like this, it's an F is equals to d by dt of m into v. My velocity remains the constant and mass is variable, so this is equals to F is equals to v into dm by dt. This is rate of change of mass with respect to time. Even this can be written. Like to observe a third case. Again, this is very rare case, but it could be there. At least mathematically we can derive this. If mass and velocity, if mass and velocity both are changing, if this is the situation that mass is changing, velocity is changing. So if this is the case, we can write like this. It's a F is equals to dp by dt. That could be written as d by dt of m into v. As both are changing, what we can write, it's an m into dv by dt plus v into dm by dt. This can be written as m into a plus v into dm by dt. So even this could be the case. When we are applying the Newton's second law of motion. But again, third case is very rare. But yes, second case is there. It is obvious, as well as it can be seen in general life as well. I hope those things are clear. Is it clear? Any issues? Any grievances? No? Everything is clear? Are you sure? Great. So we already know what is the unit of forces and all that stuff. In CGS it's a gram centimeter per second square. In SI it's a kg meter per second square. In CGS its unit would be a dyne. It would be a Newton. 1 Newton is equals to 10 to the power 5 dyne. And that dimensional formula, it's an m1 l1 t minus 2. One more very important thing is force is vector quantity. Force is a vector quantity and its direction is same as the direction of the acceleration. Now let's look out the certain more units of the forces, and this are known as the gravitational units of the forces. Two units. It's first is the kilogram weight. In short, we call it as a kg weight. It's a kg dot weight. And the another, it's a gram weight. It's a gm multiplied by weight. This two kilogram weight and gram weight are known as the gravitational units of forces. So we can say it's a 1 kg weight, which is equals to 9.8 Newton, or 1 kilogram force. This can be represented by both the way. It's a 1 kg weight or it's a 1 kilogram force. It's a 1 kgf. That should be is equals to 9.8 Newton or g Newton, or 1 gram of weight or gram weight. That can be written as, or it would be equivalent to 980 dyne. So if somewhere I have been given that force acting on a system, it's 10 kg weight. So first I need to apply that 1 kg weight is equals to 9.8 Newton. So this is equals to 10 into 9.8, which should be a 98 Newton. This is to be applied. Yes, so when they say kg dot weight, it's a kg weight. I need to multiply it with 9.8 Newton. Is it clear? Is it clear? Great. So let's have a look to the applications of Newton's second law. Let's have a look. So we are heading towards the applications of Newton's second law of motion. So let's have a look to the applications of the Newton's second law. Let's suppose u and v are the initial and final velocities of a particle of mass m, and average force acting on the particle in a time interval dt is required. So what we know that F is equals to rate of change of momentum. When I say rate of change of momentum, I mean it's a change in momentum with respect to time. So if I calculate the change in momentum, I can write like this: it's a final momentum minus of initial momentum divided by time t if I want a scalar form. So that can be written as F is equals to mv minus mu divided by dt. That means within this frame of time, sorry, within this frame of time, my velocity of a particle is changing from velocity u to the velocity v. Here one thing you must consider is that v is the vector and u is the vector. So when you calculate the momentum, you always look forward for the direction as well, because this is a vector quantity and that cannot be treated only just like this is speed. No, this is not speed, this is velocity. Why I am saying this? Let's have a look to this second application and you might get an idea. That let's suppose this is the situation that if a ball of mass m is there and it strikes a rigid floor normally and it rebounds with the same speed. It rebounds with the same speed. Here I have used the word speed, so I'm talking about the magnitude only. So let's suppose a object is there. It was initially at rest and it is moving in this direction. It has been strike at this. It has been strike with the rigid floor. When it has reached here, its velocity would be v. So its momentum can be written as minus of m into v. I have taken it minus because I consider that downward direction is taken as a negative. Downward direction as a negative and upward direction as a positive. That is obvious. Yes, so when it strikes here, it is moving in upward direction with same speed. So this is m into v. So while I calculate the change, what I can write? I can write it's a mv minus of m into u divide by time t. So when I calculate this is mv minus of mu divide by time t. This is positive final velocity, it's a m into v. This is negative, so it's a negative positive, which is m into v divided by time t. So this is mv plus mv, that is arrived at 2mv by t. I hope these things are clear. So if you by mistake taken this as a scalar, your answer would be a 0, and that was the biggest mistake that you committed while doing this numerical. I hope these things are clear. So I again repeat that this is vector. Do not treat it or do not make a mistake by taking it or by considering it as a scalar, because it will make our answer would be a 0, and definitely one of the option would be a 0. So you might get tempted from there as well. So please look at this very carefully and do the numerical accordingly. Now let's look at the second application. Let's suppose an object is there and a ball is there having mass m and velocity v. It is moving towards the wall. While making an angle theta, and it strikes a wall while making an angle theta with the vertical, and it gets rebound. In this direction. So if I write the cos component and sine component, let's look at this. This is the velocity v. So if I write cos component of this, it's a v cos theta, and this should be is equals to v sine theta. If I write this with respect to alpha, so this is, let me replace this with presence of alpha. So this could be written as, this is v cos alpha, and this is v sine alpha. This is V cos alpha that I have written over here, and it is going to rebound in this direction while making an angle alpha. So this would be V cos alpha, and this would be V sin alpha. Now let's suppose assume that it is at time t is the time of contact of ball with the wall. Then what I need to find out, I need to find out the force on the ball. So how can I do this? What I can return is that F is equals to mv minus of m into u divided by time t. Now what is the value of an v? What is the value of an v? If I try to like, it's an, let's say, an initial velocity u. That initial value u can be written as minus of, why minus? Because it is moving in negative x direction. It's a minus of v cos alpha I cap, and it is moving in negative x direction, negative y direction, so it's a minus of v sin alpha j cap. What is the final velocity? It is the velocity after rebounding with the wall. So final velocity, that would be is equals to, this is moving in positive x direction, this is plus v cos alpha I cap, and this is moving in again negative j direction, it's a minus of v sin alpha j cap. So if you subtract this now, v minus u, you might get it's a 2mv cos alpha by t. It's a 2mv cos alpha by t. I hope these things are clear. Is it clear? Is it clear? Great. Now let's look one more example like this only. Let's say this is the wall, and your object has strike it like this, and it is going to rebound with the same velocity. Let's say something like this, that this is the velocity v and this is the velocity v. In the previous example, we have an angle theta, or we have an angle alpha with horizontal. Now let's say we have an angle alpha with vertical. It is something like this. This is alpha, this is alpha. So all other parameters are the same. I want to find force acting on the wall. You need to find out the force acting on the wall. So if this is v, I could write it's a v cos alpha, this is v sin alpha. These two are the input terms, and after rebounding this could be written as v cos alpha, and this could be written as v sin alpha. So while writing out the u, it's an initial velocity before striking the wall, it's a minus of v sin alpha I cap minus of v cos alpha j cap. This is the initial velocity. And what about the final velocity? The final velocity is, it's a plus v sin alpha I cap minus v cos alpha j cap. So if I put up, it's a delta p, it's a m into bracket v minus of u, final velocity minus initial velocity. This is equals to m into, let's look at this very carefully. This is v sin alpha I cap minus v cos alpha j cap minus of, so this is plus, it's a plus v sin alpha I cap minus plus v cos alpha j cap. So this two terminology will be cancelled out, and I have been left with the 2v sin alpha I cap. So this is equals to 2mv sin alpha I cap. This is just the delta p you required in force. It's a F that should be equals to delta p by delta t, that should be written as 2mv sin alpha divided by delta t. This is the force acting on an object. I hope these things are clear. Is it clear? Any doubts? Is there anything? No? Great. So do you have any conclusion from this? Do you have any conclusion from this, that which component is cancelled out and which component will remain? Do you have any idea? Let's look at this again. You might get an idea that this was the alpha, this was the angle alpha. That means I have made an angle with the horizontal, and the term that remains, is v cos alpha. Here in this situation I have made an alpha here, so the sine alpha component would be on this side, and the term that remain is 2mv sine alpha. So if you cannot get it right, let's have a look. That let's suppose this is the situation. Object get it hit over here and rebounding from this place. Yes, and this is angle alpha. This is angle alpha. So always component which is perpendicular, to the colliding surface is conserved. So you need to always consider this many thing only, that this is V cos alpha, and that should be is equals to, this should be is equals to V sin alpha. So delta V, because this is even the same velocity, delta V would be equals to 2V cos alpha. This would be the final answer. No need to prove every time that this is cos alpha, this is sin alpha, and all that kind of stuff. No, not at all required. You just need to check that which component is perpendicular to the colliding surface. Always the component which is perpendicular to the colliding surface will be conserved. I hope these things are clear. Yes, so tell me, let's say this is the situation, that ball is moving in this direction and it is rebounding in this direction. Now my angle, it's let's say angle beta is over here, and this velocity is V. So delta V, that the component that is being saved, it's this is V cos beta, and this is V sin beta. Now tell me, which component is perpendicular to the colliding surface? Yes, you are right, it's a V sin beta. So delta V, that should be is equals to 2V sin beta. I hope these things are clear. And then if I required force, multiply with mass, which will give me a momentum, and then divide it by time t. Is it clear? Is it any doubts? Anything? No? Great. Let's move to the next application. This is very interesting. First tell me, have you seen this kind of situation? Let's suppose this is the person, and it is holding one of the pipe through which water is coming, and let's assume that water is moving in the horizontal path and it is going to strike the wall horizontally only. The pipe that person holds is of area A, and let's say that velocity with which water is coming out, is velocity V. I need to check it out. What should be the force acting on an object? So what I can write, it's an F is equals to, delta P divided by delta T, and that can be written as 2mv by T. But let's assume that I don't want mass. So I can replace this. That we have this relation, density equals to mass by volume. So mass is equals to density into volume. Volume can be written as area into length divided by V divided by T. This length by time can be considered as in velocity, and this comes to in 2 rho a V square. This is the answer. Yes, this is F is equals to 2 into rho into a into V square. I hope these things are clear. Is it? So can you do this kind of question? Is it possible? Is it? Are you sure? Great. So can we move to the numericals? Can we? Let's have a look. Suppose this is the floor. This is height 50 meter, and you are dropping from here. So this ball will strike this and will be rebound to this height. Yes, and if ball is in contact with floor for 0.1 second, find out force acting on floor. Yes, this is what you require. So what you need to do, my basic formula should be F should be is equals to delta P divided by delta T, while delta P could be written as mv minus of mu divided by delta T. So you need to find out a velocity at this place. How could you do this? I hope you remember this. It's a v should be equals to root of 2 into g into h. So that should be is equals to 2 multiplied by 10 multiplied by height. It's a 50. This is 52s are 100 and 110s are 1000. Yes, 1000. Let's suppose assume that mass of an object is 1 kg. So this is equals to m into bracket v minus of u divided by delta t. As they said that it is reaching or it can achieve that height only. That means when I say that height, I am considering it's a 50-meter height. So this v and u magnitude wise same, and that could be written as 2mv divided by t. So let's put up the value. It's a 2 multiplied by mass, which is of 1 kg, multiplied by velocity. Velocity of 52s are 100, 110s are, it's 110s are 1000, and that can be written as it's a 52s are 100. So that is 10 root 10 divided by 0.1 second. So it's a 1 into 10. So this is 10 into 10, 100, 100 into 2. It's a 200 root 10 Newton. I hope even you get the same answer. Did you? Did you get the same answer? Do you? Are you sure? So can you do this kind of question? Is it? Great. So shall we move to the next question? If a soldier is firing n bullets per second, if a soldier is firing n bullets per second, each bullet is having mass m and it is leaving with velocity u. It is leaving with velocity u. Then find out force acting on the shoulder of soldier. Yes, this is the question. If you wish, you can go one more time. Let's suppose if a soldier is there and he is firing n bullets per second. This is the, so I can define it's a n, that is total number of bullets n divided by time t. This is n is the total number of bullets. This is total number of bullets, and t is the time. So this is number of bullets per second. It's a number of bullets per second. Yes. What do you want to find out? You want to find out the force acting on the shoulder of a soldier, because he is holding his gun on the shoulder. So how can you do this? Let's say we can write like this. It's a F is equals to m into v by t. This is for single bullet. This is for single bullet. He is firing n bullets per second. So he is, let's say, write like this. It's a n by t. So now n by t can be written as small n. So this is F, which could be written as n into m into v. This is the force acting on the shoulder of a soldier. That's it. You did it. This force is also called as the recoil force of gun. This is recoil force of a gun. Yes, one more thing. If you can also write like this, it's a F is equals to n into m into v divided by t. Yes, so here capital N, it's a total number of bullets. Total number of bullets that has been fired. And t is the time taken to fire that bullets. It's a time taken. Is it clear? Is it? Any doubts? No? Great. So will you be able to solve this kind of question? Will you? Are you sure? So shall we move to the next concept? Let's begin. It's a concept of impulse. Now let's first look at that. What impulse is? We can say impulse is the product of force and time that produces a finite change in the momentum of the body. That we call as an impulse. So let's consider it as something like this. It's a F is equals to mv minus mu by t. So this is F into t, which could be written as mv minus mu. Then this term, the term that we call as an F into t, this is known as the impulse. This is impulse. So consider the different cases. Let's say consider that it is a collision between two billiard balls, and while they collide, they can create a finite amount of change in each of the striker and each of the skew. Yes, so it can change the velocity of both. Second case, it's a nail driven into a wall by striking it with a hammer. Yes, even the contact force between the hammer and the nail is for a fractions of second, but it can create a more severe effect due to certain reasons. That reasons can be find it out with the help of impulse, or that impact can be calculated with the help of impulse. I hope these things are clear. Is it? So let's calculate first and consider unit of impulse. It's a force into time. So this is equals to, in CGS system, force can be written as dyne. Time is mentioned as second. In SI system, it's a Newton into second. Dimensional formula of impulse, this is F into t. It's an vector quantity, and the direction of impulse is in the same direction of force. So while I write F into t, I can write it's a kg into meter per second square multiplied by second. The second has gone and it remains a kg meter per second. So it's a dimensional formula. It's an m1 l1 t minus 1. I hope those things are clear. Is it clear? Yes, it is the same thing. It is the same thing that we calculate for the delta p, which is change in momentum. So either change in momentum or impulse, are same thing dimensionally as well as according to the units. I hope this is clear. Is it clear? Yes. Now let's suppose if the force is constant, then I know that J is equals to F into T can be written. Yes, as well as according to the Newton's law, we know that this is F is equals to dP by dt. So if I write it's an F into dt, that would be equals to dP, which is change in momentum, and change in momentum can be written as final momentum minus of initial momentum. It is a P2 minus P1 that can be written as m into v minus of mu, and this impulse can be written as f dt, or that is a change in momentum. So this is the first approach. This is the first approach to calculate the impulse. First approach, it's f into t. A second approach to calculate the j, it's an impulse, that is to calculate the delta p, to calculate the change in momentum. I can easily get it done. That can be done easily, very easily. I hope those things are clear. Is it clear? Now let's look at the one of the most favorite approach of the examiners. That let's suppose they have given that your force is variable. The force is variable and you need to calculate the j. So what you are supposed to do is you need to just integrate your force with respect to time from initial time to the ending time. Yes. Another approach. It's an area, let's say area under f versus t graph is given, and you need to calculate impulse from here to here. So one of the approach to calculate the area under the curve, and if this is not the case, just integrate it and get it done. Yes, these are the different approaches from which questions have been asked. And first we are going to look into the different applications, that means the practical applications of the impulse, and then we will move to the numericals based on the impulses. Yes, so let's first look at the applications of the impulse. This all are the practical applications, and you might have come across this applications in class 9 as well. Yes, so this is just for the revision purpose, that we get an idea that what impulse is. That let's suppose for a given impulse, that means impulse is constant, the average force is inversely proportional to the time for which force is acts. It's something like this, that is I is equals to f into t. And if I take I as a constant, that means force is inversely proportional to the time. That means if time is very short, then the amount of force that can be applied is very, very high. This is the situation in many of the cases. Let's have a look. Let's suppose a person is there which is falling on a concrete floor from a certain height, receives injury more than when he falls from the same height on the loose soil, because in the loose soil he is going to take more time to reach the ground surface, while here this is the solid surface, it is the concrete floor, and he is taking a very less time. And when he is taking very less time, his force or the force acting on his body would be higher, while here the force acting on his or her body would be lesser. Yes, great. One more example, it's a breakable articles like Chinaware would be there, or television sets would be there, are transported from one place to another by backing them with felt or styrofoam. I hope those things are clear. Yes, because it is something like this. A cushioning effect has been created, and here our object has been placed here, let's say something like this, so that this can create these two boxes can create a cushioning effect for them, and this will save this article. Yes, because it will not allow a larger amount of force to be acted on this article. Is it clear? Is it? Let's have one more example. Shock absorbers are there. I hope you understand what shock absorbers are there. In non-technical term, they are called jumpers as well. Yes, shock absorbers are used in vehicles to reduce the magnitude of impulsive force. This is the same. It increases the time acting on an object, and when it increases the time, it will reduce the force. So if time is increasing, your force will decreasing. And one more, it's a cricketer lowers his hand while catching the ball to reduce the impulsive force. I'm sure you might know all this. Yes, so please do remember this. This is important. This all are the important for subjective examinations. Please do remember this. Yes, let's now look at the MCQs. Formula for impulse. What is it? We say it's an F is equals to mv minus of mu divided by t, and if I write, it's a f into t, which could be written as mv minus mu. This f into t, this I, could be written as delta p, change in momentum, or it's a f into t. So here the given answer is force into time. Even one of the options were there. If one of the options were there, which is change in momentum, even that would be the answer. So this could be force into time, or this could be change in momentum. I hope these things are clear. Is it? Great. Next, what is the dimensional formula for impulse? It is same as the momentum. It is same as the momentum. So we can write like this. It's a kg meter per second. For dimensional formula, it is m1 l1 t minus 1. So this would be the answer. I hope these things are clear. Is it clear? Is it clear? Are you sure? Okay, so let's look at the questions. Find impulse acting on an object. Find impulse acting on an object for given x versus t graph. So let's have a look. This is x versus t graph is given, and graph is something like this. Let's say this is the 0 second, this is the part 5 seconds, this is the 10 seconds, and this is, let's say this is in meter, this is in seconds, and it is given that mass of an object is 1 kg. Now you need to find out impulse first at t is equals to 0 seconds, second at t equals to 5 seconds, and third at t equals to 10 seconds. You need to find out impulse at these 3 instances. It's a t equals to 0, t is equals to 5, and t equals to 10. Now tell me, how could you calculate this? How could you? So first thing, when calculating the questions of the impulse, what I need to consider is that I am having 2 approaches. First approach, which tells me that I should go with the mv minus of mu by t, that means f into t, which will give me an impulse, which is change in momentum. This is the first option. Or second approach to find out the I is delta p. So either to calculate f into t, which can lead me to the impulse, or either to calculate the delta p. Now what delta p is? It's an m into delta v. So if I consider the situation, maybe I get f into t, but it would be a longer one approach. But I can calculate m into delta v easily. How? Because this is the graph for the displacement versus time. And when they have given the graph for the displacement versus time, it is easier to calculate the velocity, and then I need to calculate the change in velocity, and I need to multiply it with mass. That will give me an impulse. So this approach in this example will best suited to me. So let's start calculating it. First at t is equals to 0 seconds. So I am observing this situation. So if I calculate that, this should be my final velocity, and initial would be this situation. So if I observe this carefully, my initial will be a 0. Final velocity, I need to calculate the slope. How? It's a change in y-axis, which is 10 minus 0, divide by change in x-axis. This is 5 minus 0. So this is 5 minus 0, 10 minus 0 divided by 5 minus 0. It's a 2 meter per second. And impulse can be written as m into v minus of u, which is equals to mass, it's a 1 kg, final velocity, it's a 2, initial velocity, it's a 0. This could be written as 2 kg meter per second. Is it clear? Is it? Great. Let me redraw the graph. This will help us. It is something like this. This is 0. This is 5. This is 10. And this would be the 10. This is x. This is t. So now I need to find out at t is equals to 5 seconds. So when I calculated t equals to 5 seconds, this is initial and this would be the final. So initial velocity, it's a slope which can be calculated as 10 minus 0 divided by 5 minus 0, which would be in 2 meter per second. A final velocity, you can observe it that this is the angle and it is an obtuse angle, and when I calculate for the obtuse angle, my slope would be the negative. This is the concept what we are using from unit number 3, motion in a straight line, concept of the graphs. Yes, so let's first calculate the magnitude. It's a 10 minus 0 divided by 5 minus 0, but it is in negative, so this would be equals to minus of 2 meter per second, and my impulse, that could be written as m multiplied by v minus of u. So this is 1. Final velocity, it's a minus of 2. Initial velocity is of 2, but here it is a minus, so this is minus. So that should be is equals to minus of 4 into kg into meter per second. I hope these things are clear. This is the second numerical. And the third case I at t equals to 10 seconds. So in this situation, my final velocity would be 0. I need to consider a final velocity over here, and this would be considered as an initial velocity that I have already calculated. This u is equals to minus of 2. So I, that should be is equals to m into bracket v minus of u, that should be equals to 1 into v, which is a 0. U, that is of minus 2, it's a plus 2. So this is equals to 2 into kg into meter per second. This is impulse, or this is what we call as a change in momentum. Is it clear? Is it? So please remember this. Please remember this pattern of question. This is important. This is one of the favorite questions of the examiners. Yes? Okay. Ready for the next question? Are you ready? Let's have a look then. If force acting on an object is given as F is equals to 4t plus 2 Newton. Find impulsive force on an object for t equals to 0 to t equals to 5 seconds. This is what you require. So first your force is constant or variable. Look at this very carefully. It's F is equals to 4t plus 2 Newton. So if I put a different value of t, I'm sure that I can have a different value of F. That means my force, the given force is the variable one. And when force given is variable, I need to take in help of integration that we have learned in the previous slides. So what I can write, it's an I that should be is equals to integration of f dt. Is it clear? And you need to integrate this. You need to integrate this from t equals to 0 to t is equals to 5 seconds. Is it clear? Is it clear? So what you need to do is you need to integrate this situation. You need to integrate this force from t is equals to 0 to t equals to 5 seconds. So let's integrate this. It's an integration of 4t plus 2 dt from t equals to 0 to t equals to 5. So that can be written as I is equals to integration of 4t, this is 4t square by 2, plus integration of 2 dt, that's is 2t, from 0 to 5 seconds, this is 2 2's are gone, and this is equals to 2t square plus 2t from 0 to 5. So that can be put up the value, it's a 2 multiplied by t square, that is a 25, plus 2 multiplied by 5. No need to put in 0, it would be an always 0. It's a 2 into 25, this is 50, plus 2 into 5, that is 10, this is 60 kg meter per second square. It's an I, impulse. That is what we require. Is it clear? Is it? So can you do this kind of questions? Can you? Is it possible by you guys to get it done? Are you sure? Great. Let's have a question of different pattern. Suppose a graph is given and the graph is of force versus time, and graph is looking like this. This is 0 seconds, this is 4 seconds, this is 8 seconds, this is 10. The force is in Newton and time is in second. So they want that to find out impulsive force acting on an object for situation shown in the figure. So what do you require? You know that F is equals to mv minus mu divided by t, which is delta p by t, as well as you know that that is F into t, that should be equals to delta p. So while I doing a multiplication, I am having an I, that should be is equals to F into t. So I need to find out area of the curve. I need to calculate the area of the curve. Now how can I calculate the area of the curve? That can be I, that should be is equals to, I can see this is a triangle, it's a half into base multiplied by height. This is equals to 1 by 2 multiplied by 8 multiplied by 10. This is 2 4s are and 4 10s are, which is a 40 kg meter per second or Newton into second. Is it clear? Is it clear? Great. So can you do this kind of questions? Will you able to solve this kind of questions? Are you sure? Are you? Great. So let's wind it up this session over here. Yes, this is all about the second law, and before we started the second law we have discussed the two things. First, momentum, then we have switched to the second law, and then we have learned the impulse. Please read this and revise this, as well as start doing the numericals of laws of motion, because this is what we can say that this is the part of mechanics which is we considered heart of a physics. If your mechanics is good enough, no one in physics can beat you. Please remember this. Yes, we are at the heart of a physics. So do as many questions as possible. Practice so many questions. This will help us. Thank you. Have a good day. Take care. Bye bye.